Is in my presentation visible? Say, coding. Sir, is my presentation visible, sir?
Yes, sir.
Sir? Sir?
Siddesh, you proceed with your friends. If I turn it on, you will get an echo, that's why.
Okay, sir. Okay, sir. Sir, can you hear me, sir? Sir? Yes, sir. Yes, sir. Good morning to one and all. Today I am here to address a seminar on the topic of biasing of bipolar junction diodes. Um, Firstly, if we see the definition of biasing, biasing basically means that we are providing optimal conditions to proceed our amplification or switching circuits correctly. That is, the transistor biasing is the process of setting a transistor DC operating voltage and current conditions. That means the uh, biasing circuit to correct level so that any AC input signal can be amplified or switched correctly by the transistor. And the need for biasing is to, while we are setting the Q point in the active region, we may get distortions or clipping of signals, which can be avoided by properly biasing the transistor. The main concepts that are involved in the biasing are operating point, stability factor, and DC load line. It is not exactly involving in biasing, but we will study biasing with these concepts involved. First is operating point. Operating point is the point of intersection of DC load line and the output characteristics of a device, which is denoted by Q. Q means quotient point. The quotient point specifies the transistor collector current and collector to emitter voltage when there is no signal at the base terminal, which is actually the output characteristic curve. And we may get the Q point. In the Q point, the values are should be it should not fluctuate, but actually it fluctuates a little bit due to the factors due to two factors, the factors affecting the stability of Q point. One is the small variation in parameter of values of transistor during the manufacturing process, and the other is due to the environmental temperature in our the room temperature in the place where we use the transistor device. And we should note that thermal runaway is a main factor which affect the efficiency of the transistor. If thermal runaway occurs, it could even damage the transistor permanently. And the other factor is stability factor. Stability factor, it is defined as a rate of change of collector current with respect to rate of change of reverse saturation current, keeping beta and VBE, that is current gain and voltage between base emitter as constant. Using this derivation, we conclude the formula of S, that is stability factor is equal to 1 plus beta by 1 minus beta into D by DIC into dB. Here the point we have to note is that if the stability factor S is larger than 1, then the stability of the circuit is poor and it will not produce a constant output. If the stability of the circuit is equal to, that is S is equal to 1, then it is properly biased and the stability would be good. And finally, the concept we are going to learn is the DC load line. DC load line is a straight line drawn between the two axes of uh, output characteristics. It shows corresponding, it is a straight line drawn on the device output characteristics, and then it shows the corresponding values of collector current IC and collector to emitter voltage VCE. That is the two axes. To draw DC load line, we should take the KVL of the output circuit, and we should keep current as 0 to get the x-axis point, and voltage as 0 to get the y-axis. Current as 0 to get the x-axis point, and voltage as 0 to get the y-axis point. That is A and B respectively. And the point of intersection with IB, the voltage output characteristic curve, and those DC load line is known as Q point, which can be seen in the diagram shown. Finally, here we are at the types of biasing. There are two types of biasing, named base biasing and voltage divider biasing. First, we are going to look at base biasing. The base biasing depends upon the applied voltage VCC and base resistor RB. If these two values are fixed and the IB is fixed, so we can call it as fixed current bias. In here, we just connect the base terminal and collector terminal to a common DC source VCC, and then we vary the values of RC and RB to get the required IB, which then biases our transistor to get the desired characteristics. By applying KVL on input and output circuits, we can arrive at the respective equations shown in the presentation. And the stability factor, by deriving, the value will be S is equal to 1 plus beta, which is the S value is greater than 1, which means that the stability of the circuit is poor. After that, we are going to look at the DC load line of the circuit. As I said earlier, we can draw the DC load line by keeping current and voltage as 0 to get y and x axis respectively, and by drawing the output characteristic curve for different IB values, we can get intersection point, which is the operating point, that is Q point of the transistor. This point can be used to make this to bias the circuit. And the second type is voltage divider bias. Two resistors RC and RE are connected in series with transistor. The resistor R1 or R2 divide the supply of voltage and give bias voltage VB. Here, even though the source is common, that is VCC, the R1 and R2 act as a voltage controller, which means the values of R1 and R2 will affect the voltage applied across VBE, which in turn we can actually set the values of R1 and R2 to get the desired voltage, and we can bias the circuit. This type of biasing is known as voltage divider biasing. As in the previous biasing, we can take input and output circuit analysis and derive the equation. By calculating the stability factor, we get that the stability factor is approximately equal to 1, which is this voltage divider bias is more stable than base bias. The voltage in DC load line of a voltage divider bias is very similar to base bias, except that the current equation is VCC by RC plus IE. Finally, if you want to design a circuit with these biasings, we should with these biasings, for base bias, if you want to decide build a circuit, you have to frame your application first. and then you have to decide the input voltage and the type of transistor you're gonna use. After that, the final step is to find RB and IC by calculating using the above equations I have shown in the types of biasings. If we calculate values of RB and RC, we can bias the circuit as of our requirements. Voltage divider biasing. In voltage divider biasing, we have few extra components to calculate, that is R1 and R2. These R1 and R2 are used to regulate the voltage that is given to the VBE, and then we have to regulate RC and RE, the collector resistor and the emitter resistor. Thank you. Yes, sir. Can you complete it, sir?
Do you have any clarification or doubt? Is this pointer is available?
Sir,
Pointer or the pencil to highlight while you take the presentation?
Is sir available, sir? That but Perry platform doesn't allow that. Sir. That is a premium feature, sir.
Oh, okay.
I have the stylus, sir. I could have used that, but platform வந்து allow பண்ண மாட்டேங்குது, sir. Premium கேக்குது, sir. Download பண்ண முடியல, sir.
Okay, yes, if it is a paid version only, you can download that. And one more thing, in the few initial slides,
Yes, sir.
you need to reduce the content. And only you need to highlight the points. Okay,
Okay,
thermal
sir.
runaway, you can bring it to the one more slide. No
Okay,
need
sir.
to put a sentence to read. Okay.
Okay, sir.
நான் பார்த்தேன், but அதை highlight பண்ண மறந்துட்டேன். ஓகேவா?
Okay,
And
sir.
one more thing, animation வரல, கரெக்டா? You are putting too many things in the single slide, but where you are going to start your discussion, we don't know. ஒரு சின்ன drawback இருக்குது இல்ல. So okay, anyhow, it's a good attempt with the good platform.
Yes, sir.
Try to find how you can make a little more think to the more clarity to the listeners. Okay, wow.
Okay, sir.
நிறைய diagrams இருக்கு, but நம்ம எங்க present பண்றோம்ன்றத clarity இல்ல. Okay, wow.
Okay.
Ajit sir, anything else? Hello.
Yes, sir.
சார் சொன்னதுதான் ஸ்லைட் நம்பர் போட முடியாது இதுல.
சார் இல்ல சார், ஸ்லைட் நம்பர் ஆட் பண்ணனும்னா அதுக்கு ஆப்ஷன் இல்லை சார்.
சரி, ஓகே. அப்புறம் நீ ஐ திங்க் நம்ம ஸ்டடி மெட்டீரியல் இருக்கிற சென்டென்ஸ் அப்படியே காப்பி பேஸ்ட் பண்ணி வச்சிருக்கீங்க, கரெக்ட்டா?
சார் காப்பி பேஸ்ட் பண்ணேன் சார். ஆனா மேக்ஸிமம் வந்து டெரிவேஷன்ஸ் தான் சார் அப்படியே எடுத்து போட்டேன் சார். கண்டென்ட் வந்து கொஞ்சம் நம்ம மாடிஃபை பண்ணுவோம்.
ஒரே ஒரு கேள்வி, பிபிடி அப்ரிவேஷன், வாட் இஸ் அப்ரிவேஷன் ஃபார் பிபிடி?
சார்
பிபிடி வாட் இஸ் அப்ரிவேஷன்?
Sir, 1 minute, sir. Can I close the meeting in A class? It's echoing, sir.
Vidyan sir, just
Siddheswaran.
Sir?
He's asking the abbreviation for PowerPoint presentation. PPT, நானே சொல்லிட்டேனா?
PowerPoint presentation, அது PPT abbreviation, கரெக்ட்டா? ஆனா நீ என்ன பண்ணிருக்கு? நீ வந்து ஹேண்ட் அவுட்ல இருக்கிற ஸ்டடி மெட்டீரியல் இருக்கிற சென்டென்ஸ் அப்படியே காப்பி பண்ணிட்டு நீ பேஸ்ட் பண்ணிரு, கரெக்ட்டா?
எஸ்
ஜஸ்ட் புல்லட் மட்டும் பாயிண்ட்ஸ் மட்டும் போட்டு அதை நீ எக்ஸ்பிளைன் பண்ணு, புரியுதா?
ஓகே சார், ஓகே சார்.
அப்புறம் நீ நிறைய விஷயம் இமேஜ் ஆயிட்டு பேஸ்ட் பண்ணிருக்க, கரெக்ட்டா?
எஸ் ஈக்குவேஷன்ஸ் அதுல கொண்டு வர முடியல சார்.
ஈக்குவேஷன் பண்ண முடியலையா, அதோ தெரியாதா? அப்படியா
சார்? பண்ண முடியலங்க சார், அது பிரீமியம் ஃபீச்சர்.
சரி, நார்மல் பிபிடில ஈக்குவேஷன் போட முடியுமா?
எஸ் சார், எஸ் சார்.
ஓகே ஓகே, சரி. அப்புறம் ஃபோன் சைஸ் வந்து கொஞ்சம் பெருசு பண்ணணும். நீ காப்பி பேஸ்ட் பண்ண, கட் காப்பி பேஸ்ட் பண்ணேனால ஃபோன் சேஞ்ச் பண்ண முடியாது. நம்ம சேஞ்ச் பண்ணனும்.
ஃபாண்ட் சைஸ் சேஞ்ச் பண்ணலாம் சார், அது கரெக்ட்டா ஃபிக்ஸ் பண்றதுனால.
ஃபோன் டைப் இல்ல, ஃபோன் சைஸ்.
எஸ் சார், எஸ் சார்.
அது கொஞ்சம் இப்ப நம்ம தனியா பார்க்கும்போது நம்ம லேப்டாப்ல எல்லாம் பார்க்கும்போது ஜூம் பண்ணி பார்க்கலாம். ஆனா நம்ம பிளாட்ஃபார்ம்ல பிரசன்ட் பண்ணும்போது கடைசியில் உட்கார்ந்து அது ரீடபிலிட்டி கம்மியா இருக்கும். புரியுதா?
எஸ் சார்.
அது கொஞ்சம் இம்ப்ரூவ் பண்ணுங்க. இனி
Okay, sir.
டைப்ஸ் ஆஃப் பயாசிங் சொல்லிருக்கியா? டைப்ஸ் ஆஃப்
Sir.
பயாசிங்.
Yes, sir.
டைப்ஸ் ஆஃப் பயாசிங். How many types?
Sir, 2 types, sir.
2 types. Confirm.
Yes, sir. Base biasing and voltage divider biasing.
நான் இன்னொரு சொல்லி அக்செப்ட் பண்ணுமா?
Sir.
நான் சொல்றது நான் இன்னர் பயாசிங் இருக்கு நான் சொல்றது நீ அக்செப்ட் பண்ணுமா இல்லையா?
Sir, no. No, sir.
சரி, நீ ரெஃபர் பண்ணிட்டு சொல்லு. நீ அக்செப்ட் பண்ண மாட்டேன்னு சொல்றா?
Sir, only 2 types of biasing, sir.
Confirm. BJT ல 2 type biasing confirm.
Sir, I read only 2 types, sir.
நீ அப்படியே படிச்சது? சரி, ஒன்னு இன்ஸ்டால் பண்ணிட்டு கிளாஸ் முடியும்னு சொல்லுங்க. ஓகே.
Yes, sir, yes, sir.
Connected to base bias.
ஓகே, அவ்வளவுதான், வேற எதுவும் இல்ல.
Sir, he said the answer. Ramakrishnan, I think.
ராமகிருஷ்ணன் அடி கொடுக்கணும். சித்தேஸ்வரன் கேள்வி கேட்டா சித்தேஸ்வரன் பதில் கொடுக்கும்.
Siddheswar, refer your class note and tell at the end of the session, okay?
Yes, sir, yes, sir. I will do.
Okay. Can I have any doubts, questions? Else we will go with this next presentation. Can I next year ready? Hello?
Yes, sir.
Yaar kanna?
Yogesh, sir.
Yogesh, present pannu people.
Sir, but I think I can't present in A section, sir. So can I get the help from Siteshwaran to present my PPT in A section?
Yes. Then audio, okay. Audio I will telecast. Okay, no issue. Siddheswara?
Yes, sir, yes, sir. 1 minute.
You present the slide in both the classes. Okay.
Yes, sir.
Ramakrishnan ready arkilla?
Yes, sir.
Okay.
Sir, yes, my screen is visible in B section, sir.
Yes, it's visible. Can I do one thing? You present
Yes,
it
sir.
here. I will present the screen in A class. Wait a minute. Yogesh.
Yes, sir.
Wait a minute.
Okay, sir.
A class students, please ensure. Can you see the slides? Yogesh, you present now.
Okay.
Can A class கொஞ்சம் ensure பண்ணுங்க. Can you see the slides?
Sir, நான் present பண்ண வேணாமா, sir?
இல்ல வேண்டாம் Siddheswar, வெயிட் பண்ணுங்க. ஏன்னா ஆடியோவும் திரும்ப இதுல தான போகும். வெயிட் பண்ணுங்க.
Okay, sir. Thank you, sir.
View slides. So can A class கொஞ்சம் ensure பண்ணுங்க. Can you? Hello? A class student? Can you see the slides? Okay. Yes, you proceed, Yogesh.
Yes, sir. Let me start the presentation, sir. Good afternoon to everyone. I hope you all guys can hear me and see my presentation. First, let me introduce myself. I'm Yogesh. Like you all, I'm a student in Karpagam College of Engineering. And today, in this beautiful day, I'm gonna do a seminar for you guys about small signal amplifiers. Let me start. And today is 7/6/2021 and it's Monday. And the topic I'm gonna take seminar is on about small signal amplifiers. And the small signal amplifier consists of some topics and I listed them here. First of all, small signal amplifiers and hybrid parameters, also aka known as H parameters, and hybrid model, IEEE standards, transistor hybrid model, analysis of transistor amplifier exact model, approximate analysis of transistor amplifier, which mean these are the topics which comes under small signal amplifiers. Okay, let me move the slide. Page 1 first. As I'm gonna talk about small signal amplifier. It's the hero, and I'm gonna tell about it first. First, why we need amplifiers? Amplifier is used in broadcasting signals because we need to broadcast signal to larger area, and we have only small input which can't cover the large area. We use amplifiers. Amplifiers are basically electronic devices which use small signal to spread out or maximize the output to which can be broadcasted to larger area, which can cover larger area. And we use transistor for this because we know transistor can be acted as an amplifier in active region. And in small signal amplifiers, we have two types, which is small signal amplifier. In amplifiers, we have two types. And first type is small signal amplifier. And second is large signal amplifier, or it is called as power signal amplifiers. As the name suggests, small signal amplifiers, it takes small amplitude signal as the input. It is mentioned in the first point. See, the amplifiers that operate with small amplitude and low or high frequency signal is called small signal amplifier. And as you guess, in high signal or power signal amplifier, it uses large amplitude signals. And as I said, a transistor is used in small signal amplifier is a small signal or low signal power transistor, and it can be treated as two-port network. Yes. As I said, transistor can be used as an amplifier in active region. And I mentioned the ports here in third point. The terminal behavior of any two-port network can be specified by terminal voltages V1 and V2. Since it is voltage, we mentioned V because it resembles voltage, and V2. As we are talking about terminals, as I said, two-port terminals, we have V1. V1 is representing input port 1, and I mentioned the inputs are in green color and outputs in red color. V1 at input port 1 and V2 output port 1. And the current, similarly, current means I1. Input current means I1 and output current means I2, and I mentioned in the colors too for better understanding. The two-port active device can be represented by hybrid model, which we'll talk about later. And do you guys have any doubt in this first slide? Any doubts, sir? Sir? Sir, can you hear me, sir? Sir, can you hear me?
Proceed.
Yes, sir. Moving to the second slide, and it's hybrid parameters. First, why we need to study about hybrid parameters? Why a new term is coming here? First, hybrid parameters are used to analyze the characteristics of the amplifier, which talks about current amplification, current gain, input impedance, 4 parameters. Here we talk about 4 parameters, and it has a condition. If the input current I1 and the output voltage V2 are taken as independent variables, the input voltage V1 or the output current I2 can be written as. When the I1 and V2 are independent variables which doesn't depend on anything, we can attain an equation like this for V1 input voltage, then I2 for output. As you can see, I mentioned the V1 input voltage as first equation and output current as second equation. And to attain the hybrid parameters, we need to make some alterations in the above equations 1 and 2. As you can see, to get H11, we need to simply we need to substitute V2 as 0. And if you substitute V2 as 0, you will get H11 is equal to V1 by I1. And H11 is nothing but the input impedance. And H12, to get H12, we need to substitute I1 equal to 0 in first equation, and we'll get H12 as V1 by V2, and it's called as reverse voltage gain. And to get H22, we need to substitute I equal to 0 in second equation, and you will get, after substituting I1 equal to 0 in second equation, you will get H22 equal to I2 by V2. And last, to get H21, we need to substitute V2 equal to 0 in second equation, and you'll get H21 is equal to I2 by I1, which is called forward current gain, and H22 is called as output admittance. As you can see, input impedance as a unit got omega, because impedance is nothing but resistance in AC circuit. If you apply DC, you will call it as resistance, and in AC voltages, AC supplies, you will call it as impedance. And same resistance omega and impedance do the same job. We'll have the same unit omega. And for output admittance, see, it's admitting the current, so it's the reverse. So we are simply reciprocating the unit of the impedance. So 1 by omega is the output impedance. And reverse voltage gain and forward voltage gain doesn't have any input units. Sorry, it doesn't have any units. They are unitless quantities. And let me move on to the slide. Yeah, hybrid model in IEEE standards. As you guys can see, it's somewhat difficult to see the numbers 1 1 1 2 2 1 2 2. It's sometimes it make you irritate. So some group of people called them as who applied some standards called IEEE standards, made some easy annotations for that, for many people to understand the terms easily. So an alternate subscript notation recommended by IEEE is commonly used as follows. If in I11 place they substitute as I, because I11 resembles the port or some port, so we resemble it as input, and 22 as output. And see, if numbers changes, I mean it's a mixture of two numbers, 2 and 1 and 1 and 2. If 2 and 1 means they apply forward, they mention F as forward transfer, because in previous slide you can see H21 is considered as forward current change, so they mention forward. And similarly 1 2 is considered as reverse transfer, so they mention it as R. And by changing the annotations, by updating the annotations, we can see the equation 1 and 2 as V1 equal to HI I1 plus HR V2, and equation 2 can be written as I2 equal to HF I1 plus HO V2. O means 2 2. In the place of 2 2 they applied O, and then in the place of 2 1 they apply F. Similarly, in the place of 1 1 they applied I, and in the place of or they applied in the place of O they applied 2 2. So, yes. And by having those equations, they proposed a model, hybrid model, and the hybrid model is given below the picture. And transistor hybrid model is the next topic, and I'm displaying the advantages of the hybrid model. The use of H parameters. Why we use H parameters in the amplifier to, as I said before, H parameters are used to analyze the characteristics, and we are going to talk about the advantages. First point, they can be determined from the transistor static characteristics curves. They are convenient to use in circuit analysis and design. Yes, hybrid parameters are used to analyze the circuit in an easier way. And third point, easily convertible from one configuration to another. We can easily convert the transistor from one configuration to another with the help of hybrid parameters. Readily supplied by manufacturers. The data sheet is provided by manufacturers in the what we need to what input voltage we need to supply and what we get as output voltage, etc. H parameters are real numbers up to radio frequencies. We won't get complex numbers till radio frequencies, and if you get complex number, our mathematical substitutions or process will get complex. So by using H parameters till radio frequencies, we'll get real numbers. It's a use of H parameters, and they are easy to measure since we have only real numbers up to radio frequencies. And the continuation of transistor hybrid, the equation of H parameters of the transistor in common emitter configuration. As I said, H parameters can be used to easily convertible from one configuration to another. We are going to talk about common emitter configuration and the equation for that. See, we introduced the new term called EE in HI and HF, HR and HO. E is nothing but we are mentioning that it's common emitter configuration. If it's a common base configuration, we used to put B in the place of E. And the hybrid model and the H parameter equation for common emitter is the circuit diagram and the transistor hybrid model. You can see below the circuit diagram, circuit schematic in the leftmost, and the transistor hybrid model in the center, and the equation. Analysis. Now we're gonna analyze the transistor. Analysis means, as I said earlier, that H parameters are used to analyze the characteristics of transistor. We can analyze the four thing: current gain, input impedance, voltage gain, and output impedance. Now we're gonna analyze one by one. And it's the, as you can see, it's the exact model diagram of the transistor. And first we're gonna talk about current gain or current amplification. It is defined as the ratio of output current to the input current. Current gain. It is defined as ratio of output current to the input current, which means divide ratio. Output current means IL. Here IL, as we mentioned, is the load current, and at last we gonna keep load, so we consider it as the output current. And by input current we are giving some input, we are giving some current in the input terminals are mentioned as 1, so I1. A1 is equal to IL by I1. And if you apply KVL equations in the output region of the circuit, you will get the current gain or current amplification is equal to minus HF by 1 plus H0 plus ZL. Sorry guys, I didn't put the calculations here since we're gonna face our CI2 in MCQ type, so I thought that it would be more than enough for you guys to give the final output. So if you have any doubts, you can refer your books, and at last you can ask some doubts with me. And the second thing is input impedance. Input impedance is defined as the ratio of the input voltage to the input current. Input impedance is denoted as Zn equal to V1 by I1. V1 by I1, and you apply KVL in the input area, you will get the input impedance is equal to HI plus HR into AN plus ZL. And HI is nothing but the input impedance, and the HR is nothing but reverse voltage gain. As we discussed earlier in H parameters, just recall that it's just simplification in terms. And voltage gain. We're going to talk about voltage gain. Voltage gain is defined as the ratio of output voltage to the input voltage. It's like opposite to the current gain. See, current gain is defined as the ratio of output by input. First, let's have gain in mind. Gain means ratio of output by input. If they ask about current gain, output current by input current. If they ask voltage gain, it's ratio of output voltage by input voltage. Basic concept is output by input. If they ask current, put L, put I, and if they ask voltage, just put V. And output means 2, input means 1. See, AV is equal to output voltage. Since it's a voltage gain, we mentioned V, and output as 2 divided by input voltage V1. And if you apply KVL equations, you will get the voltage gain for exact model. I'm talking about exact model characteristics here. Okay. V2 by V1 equal to AI into ZL by Zin. And Zin is nothing but the input impedance, which is above that voltage gain. You can see input impedance Zin. And AI is ZL is the output current, and AI is nothing but current gain. And finally, output impedance. Output impedance is mentioned as Z out. And similarly, like voltage gain and current gain, you have the same basic concept here. If impedance means it is nothing but input divided by output. See, it has input divided by output for input impedance. And for output impedance, we're gonna take output by input. For input, you're gonna have a ratio of input by input terminals. That means input voltage by output input current, and for output impedance you're gonna have output voltage by output current. Simply just see impedance. So okay, they are asking impedance, and check the before term whether it's input or output. If it's input, just simply put input voltage by input current. And if they ask output current, output impedance, just simply change the 1 into 2. You will get the basic formula of output impedance. And if you apply KVL in both of the circuits, you'll get output impedance C out is equal to 1 by H0 HO minus HF HR by RS plus HI. And HO, HF, HR are previously mentioned in the hybrid parameters. You can refer them to know what this means by HO. And approximate analysis of transistor amplifier. Now it's like it's a subdivision of exact model. Just we need to take two things from the exact model, that is HR and HO. We're gonna remove the HR and HO stuffs here, and we get the approximate model of the amplifier. And simply we need to analyze, and already we have the analysis of exact model, and we're gonna simply eliminate the HR and HO terms. So just simply substitute 0 in HR and HO places in the current gain of exact model, input impedance of exact model, voltage gain of exact model, and output impedance of exact model. Now, let me say about the current gain or current amplification of approximate model. For exact model, we found that current gain is equal to minus HF by 1 plus HO ZL. Now, we need to substitute HR is equal to 0 and HO equal to 0. Now, just examine the current gain term. You can see we don't have HR term here. Only we have HO term. Just simply put 0 in the place of HO and you will get minus HF by 1, which is A1 equal to minus HF. Because we substitute HF equal to 0, 1 plus 0 equal to 1, and HF by 1 minus HF by 1 is simply minus HF. And similarly for the input impedance, we got input impedance as HI plus HR into A1 ZL for exact model. Now we need to find for approximate model, and for approximate model we need to substitute HR equal to 0 and HO equal to 0. We have the term HR here. Just substitute HR equal to 0 in this term, and HI plus it will become as HI plus 0. See, HI plus 0. So simply we can mention Zn equal to HI for approximate model. And third, voltage gain or voltage amplification. For exact model, we got the voltage gain as A1 into ZL by Zn. Here we don't have any parameters, hybrid parameters itself. We don't have H thing itself, but we need to convert it for approximate model. So as I got the input as I got the input impedance, as I got the current gain here, current gain for approximate model, we can substitute that here. We got current gain for approximate model as HF. AI equal to minus HF. Just substitute in the place of AI minus HF, and for input impedance we got, wait a minute, and for input impedance we got HI for approximate model, and substitute the thing in approximate model for voltage gain. You get the approximate model voltage gain. And finally, output impedance. Now we have every H terms here. See, HO, HF, HR, and HI. But we need to substitute only two hybrid parameters as 0. That is HR and HO. Now substitute HO as 0 and HR equal to 0, which results in 1 by 0 minus 0, which is 1 by 0, and 1 by 0 is infinity. So for approximate model, the output impedance is infinity. And that's it, guys. Thank you for listening. And I need to mention one thing. I need to thank Rajiv Vignesh for making this PPT, for making this beautiful PPT. Without him, I wouldn't be able to take seminar today. And thank you, Rajiv Vignesh, for making this PPT for me. Thank you, and thank you, sir.
Okay, we will come to your feedback later. Okay, wow.
Yes, sir. Okay.
More presentation left. Ramakrishnan.
Yes, sir.
Okay, please start your presentation, please.
Yes, sir. 1 minute, sir.
Yes. Yokesh, wait பண்ணனும் presentation முடிச்சிட்டு.
இல்ல சார், கிளாஸ்ல தான் சார் இருக்கேன். And Rajiv Vignesh தான் சார் அந்த PPT ப்ரிப்பேர் பண்ணான் எனக்கு.
Is it visible, sir?
Visible. Continue, Ramakrishnan. Students, please ensure you can view the presentation from Ramakrishnan in both the classes. Yes, proceed, Ramakrishna.
Okay. Good afternoon, everyone. Today, I have been assigned the seminar topic on common emitter amplifier. When we think about common emitter amplifier, this is the diagram which should be coming to your mind. When we look at this diagram, we can observe two things. The construction should be very familiar to you all. Let me explain the construction first. The construction is composed of a voltage divider bias circuit configuration and the common emitter configuration. If you can see that, one second. If you can see, this part is the common emitter configuration, and this whole part is of the voltage divider configuration. So in voltage divider configuration, we'll be using 4 resistors: collector resistor, emitter resistor, and the 2 series resistors play an important role for biasing. That is these R1 and R2. There might be a question in your mind, why voltage divider bias configuration? Because if we compare voltage divider bias with the fixed bias, there will be the difference between the stability. The stability of voltage divider will be much better than the fixed bias. And you might ask, why C capacitors are added to this circuit? That's because we'll be in an amplifier, we'll be using 2 sources, that is sinusoidal AC source and a DC source. So obviously at some point there is a chance that AC or DC might get mixed. That might cause some stability issues in the amplifier. For that purposes, we'll be using capacitors to block off the DC. The next part we'll be moving on to is reactants. Before we get into reactants, we'll be discussing why we use reactants. You might be wondering that we'll be using capacitance, but have you wondered there is another device which can store energy? That device is nothing but inductor. Now, the basic difference between capacitor and inductor is what? Is because capacitor is a device which stores energy in the form of electrostatic. But inductor stores energy in the form of electromagnetic. We know that capacitor can block DC. At the same time, AC will be able to block inductor will be able to block AC. To solve this problem, we'll be using a resistor. You might have studied earlier that resistor can also be called as reactants, that is in the form of this variable representation, that is X, C, and XL. This is the reactance. This XL is the reactance of inductor, and XC is the reactance of capacitor. Now there is this table. This table is quite useful because it will be able to help us distinguish the operations in this amplifier later in the slide. Now what we want to notice is that a reactance has two operations, both in DC and AC. It will be varying according to the input we are giving. So when frequency is equal to 0 in DC part, we know the equation XC is equal to 1 by F. How did I arrive to this conclusion? XC is equal to 1 by omega C. This omega can be written in another form, which is 2 pi F. So if we conclude this, 2 is constant, pi is constant, you can assign it as 3.14 or 22 by 7, and C, which will be given to us according to the capacitor value. The only thing which is variable is F. So we arrive to the situation where XC is equal to 1 by F. So if we increase the capacitance, reactance capacitance, the frequency of it will decrease. So according to it, we have multiple results. We'll be discussing that now. So in DC, if the frequency is equal to 0, 1 by 0, simply reactance will be equal to infinity. Now when the reactance is infinity, this becomes open circuit. We all know if there is open circuit, there is no chance for the electron to flow through here. So that's why it won't allow DC. Now we'll see operation in an AC. If the frequency is very high, it will be resulting to 1 by infinity. 1 by infinity is where reactance is equal to 0. So there will be no disturbance, which ultimately leads to becoming short circuit, that is closed circuit. So now electrons will be able to flow in this closed path. We'll be moving on to the next slide. Now we will be discussing why we have implemented input coupling capacitor, output coupling capacitor, and bypass capacitor. First, we'll look at input coupling capacitor. What this does is it couples the amplified small signal AC input to the base terminal of BJT, nothing but your common emitter. So this will couple here. This is what it does. The input coupling capacitor will couple the AC input to the base terminal of this BJT. The next is output coupling capacitor. What this does is couples the amplified output signal from the collector terminal of the BJT to the load resistance. Now there's an interesting function for bypass capacitor here. It's where it's connected with this resistance RE. So whenever the frequency is high, it travels only through bypass capacitor. The reason behind this is because the reactance we have studied before in AC. We have studied that if the frequency is high, it will become infinity. So ultimately the reactance will become 0. So the current will pass through here. We'll be discussing a little more in depth about why the bypass capacitor is actually implemented in this circuit. What it does is it bypasses AC signal. It bypasses AC signal to the ground terminal by avoiding the degenerative effect. The degenerative effect is an effect caused when current flows through here. So when current flows through RE, it will create a degenerative effect. This degenerative effect will proportionally cause less gain, which ultimately leads to the amplifier's performance. So this won't sell properly in the market. For that, we cannot permanently remove it. Thus, the presence of C bypass capacitor reduces the generative effect or improves its voltage gain. Next, we'll be moving to the operation of the common emitter amplifier. Now there is a set of waveforms here. We'll be discussing it one by one. Here you can see the input of AC. So when we give AC input signal, the Vs, if we give input Vs, VB voltage generates. So in the same sense, if Vs increases, VB also increases. Proportionally, you can relate it with if there is an increase in VB, it also raises the collector current IC. From where did I arrive to this conclusion? It's this equation IC equal to beta into IB. We have used this in our problems to find the collector current. So if IC increases, proportionally IB also increases.
Ramakrishna. Hello. Sir.
சார் இது
கட் ஆயிடுச்சுன்னு நினைக்கிறேன். சரி, ஓகே. ராமகிருஷ்ணன் நெக்ஸ்ட் வந்து இவங்க தானே பண்ணும், சமிர்தா தானே பண்ணும். சரி, நீங்க எந்த கிளாஸ்ல, பி கிளாஸ்ல பிரசன்ட் பண்றீங்களா?
ஓகே சார்.
பிரசன்ட் பண்ணுங்க. இஃப் he joins back we will continue that. ஓகே, 10 minutes தான் இருக்கு, நீங்க பிரசன்ட் பண்ணுங்க.
Sir, visible, sir?
Yes, visible. Let me present the screen in B class, A class. A class students, please ping my ID. Okay. Is it my screen is visible? A class?
Yes, sir.
Yes. Yes, Samartha, you continue.
Good afternoon, everyone. I'm going to say about transistor. Transistor is a small 3-terminal device. It is a considered semiconductor. It controls the flow of current between two terminals by varying the current or voltage of the third terminal. Transistor was invented in the year 1947. It is of two types, BJT and FET. The main use of transistors are switching and amplification. BJT, Bipolar Junction Transistor, it is a current control device. The conduction of current is by both minority and majority carriers, so it is called Bipolar Junction Transistor. Constructions. Transistor consists of 3 separate regions and 2 PN junctions. The middle region is called base and outer regions are emitter and collector. The width of collector is greater than emitter and base. While in doping, the emitter consists of highly doped and collector is moderately doped. Base is lessly doped. The collector is larger in size to dissipate heat. Types of BJT, NPN and PNP. In NPN, P is sandwiched between 2 N regions and PNP, N is sandwiched between 2 P regions. PNP and NPN can be differentiated by arrowheads. This arrowheads represents the direction of flow of current. In NPN, electrons are majority carriers and PNP, holes are majority carriers. Modes of operations. BJT can be operated in 4 modes. They are active mode, saturation, cutoff, and inverse active. Active mode acts as an amplifier. It amplifies the signal. Saturation mode is closed circuit and closed switch, while cutoff region is open switch. Inverse active is reverse of active mode. In this process, attenuation takes place. Junction base to emitter junction is forward bias and base to collector junction is reverse bias in active mode. The depletion region decreases in base to emitter junction, while in base to collector junction the depletion region increases. In saturation mode, base to emitter junction it is forward bias and base to collector junction also forward bias, so the depletion region in both the junction decreases. In cutoff region, Both are reverse biased, so the depletion region increases in both junctions. In inverse active, the base emitter is reverse and base collector is forward, so the depletion region increases and decreases respectively. The function of emitter terminal is to inject or emit the base electrons, while in PNP it emits or injects holes. The base passes the electrons or holes onto the collector. If we consider NPN, when NPN junction is created, the diffusion takes place. Hence, recombination of holes and electrons takes place. This results in the formation of depletion regions. In this, the base to emitter junction is forward bias and base to collector junction is reverse bias. If we consider base to emitter junction, the depletion region reduces. This results in the flow of majority carriers in abundance after cut in voltage. The current flows through the emitter terminal is IE and the current flows through the collector base terminal is IB. IB can be measured in microampere. In this regions, the current flows through in two directions, one by base terminal and by collector terminal. Base is highly lightly doped, so the conductivity is very less in this base. Then if you consider base to collector terminal, it is reverse bias, so large number of carriers drift into the collector region due to formation of VCC. It results in the formation of IC current, and also it creates minority current, which is ICO. Therefore, total current can be written as IC majority plus IC minority. By equilibrium condition, we know that the current enters into the circuit is equal to the current flows out of the circuit. Therefore, IE equal to IB plus IC. The early effect. If VCC increases, the depletion region increases since it is reverse biased. This causes decrease in the width of the base region. This base width depends on the VCC. This is known as early effect. The consequences of early effect is IB current decreases and emitter and collector current increases. Punch through. When the base width becomes zero, extremely zero, if VCC increases abruptly, this condition is known as punch through. Thank you, sir.
Anyhow, we come to end. Dear students, sorry for the discontinuity in the seminar topics. Okay, you know, you people struggled to present your things. Don't worry. Whenever you get the chance, do practice for this. Okay, see, many of them created the slides well, but they are worrying about the how to present that without laptop. Are you unable to point the things? Even in mobile phone, you can find the pointers and all. Samartha, pointers and find பண்ணி நம்ம பாயிண்ட் பண்ணி காட்டணும். புரியுதா? ராமகிருஷ்ணன் ரொம்ப கிளியரா பிரசன்ட் பண்ணி கிளாஸ் எடுத்துட்டு இருந்தான். கரெக்டா?
Excuse me, sir.
Actually, he came back, I think. Okay, Ramakrishnan.
Excuse me, sir. Current cut ஆயிடுச்சு sir. நான் முடிக்கவே இல்ல.
Ramakrishnan, don't worry, Ramakrishnan. You shown all the output waveforms. Am I correct in the common emitter? That is enough for them. Yes, that is enough for them to refresh. So the thing is that this is your CA2 portion. Start from your BJT to MOSFET frequency response. Okay. So it is some little lengthier topic. Your friends refreshed your BJT. Recently only we finished the MOSFET. Do one thing, be genuine, take your class notes as well as your handout, refer it, okay, read it once, and even you can take this seminar class for your to reference your points. They made it some slides. We will ask your friends to share your their slides in PDF format at least. Thereby you can take that. Regarding the feedback about the Yogesh, is this Yogesh? Who made the slides?
Raja
Slide photos.
Raja Vignesh.
Raja Vignesh. Okay. Raja Vignesh unable to type many of the equations. Therefore, he made the all the equations into an image. Am I correct, Raja Vignesh? Raja Vignesh?
Yes, sir.
Yes. Okay. We will teach you. We will teach you how to type the equations in the PPT also. Okay. See, whenever you start do some work, then only you will find the difficulties. Am I correct? So, as far Yogesh is concerned, see, everyone have a go, other than Siddheswaran, everyone have good sound in their audio. Am I correct? So audio nalla irukku ellarthukkum. Language is also well for many of them. So நீ என்ன பண்ணணும்னா கான்செப்ட் மட்டும் கொஞ்சம் கிளியரா மைண்ட்ல வச்சுட்டு கொஞ்சம் கிளாரிட்டியா ப்ரெசென்ட் பண்ணணும். And one more suggestion, whenever you present your slide using your mobile phone, the first and foremost thing, you need to block all the notifications. Okay?
Yes, sir. Yes, sir.
Notifications may not be nice all the time. நம்ம என்னென்ன இதுல இருக்கோன்றதை அதை ஒரு ப்ரெசன்டேஷன்ல காட்டி கொடுத்துரும். ஓகேவா? ஸோ நோட்டிஃபிகேஷன் ஸ்டாப் பண்ணிட்டு தான் உங்க மொபைல் ஸ்கிரீனை ப்ரெசென்ட் பண்ணணும். ஈவன் இஃப் யூ ப்ரெசென்ட் யுவர் லேப்டாப், நீ எந்த ஃபோல்டரை வியூவர் காட்டுறன்றதை யூ ஷுட் பார்த்துக்கணும். நம்ம கொஞ்சம் கிளீனா இருக்கணும். நம்ம சைட்ல எஜுகேஷனுக்குன்னு சொல்லி சில ஃபோல்டர் கிரியேட் பண்ணிக்கும். அந்த ஃபோல்டர்ஸ் மட்டும்தான் we need to present to others. ஓகேவா? எஸ் அது பார்த்துக்கணும் யோகேஷ். தென் ராமகிருஷ்ணன் வந்து ரொம்ப ஸ்லோ அண்ட் ஸ்டெடியா போயிட்டு இருந்தார். பட் இன்டரப்ஷன் ஆஃப் பவர் மேட் ஹிம் டு லிட்டில். அண்ட் ஆஸ் யூஸ்வல் சஜித் சார் சொன்ன அதே சஜஷன்ஸ் தான். என்ஷூர் யூ ஹேவ் த ஸ்லைட் நம்பர்ஸ் இன் யுவர் ஸ்லைட் அண்ட் ஆல்சோ பவர் பாயிண்ட் ப்ரெசன்டேஷன் பாயிண்ட் பை பாயிண்ட் கொஞ்சம் ப்ரெசென்ட் பண்ணணும். But we will give some theory content in our slides. Why? You people note down a few things. Okay, va? But நாங்க பாயிண்டா போட்டு எல்லாத்தையும் தியரியா நாங்க டிக்டேட் பண்ணோம்னா you people will feel little difficulty to take the notes. ஸோ அதனால தான் நாங்க கொஞ்சம் தியரி கண்டென்ட் ஆட் பண்ணி எழுதுறோம். ஓகேவா? பட் whenever you get a chance to present, stick with the points. Point மட்டும் அங்க ஹைலைட் பண்ணிக்கணும் புல்லட்டின்ஸ்ல. Then you need to elaborately you need to discuss. Okay, that's all. Samartha வந்து கொஞ்சம் fear இருக்கு, கரெக்டா? அந்த fear கொஞ்சம் கரெக்ட் பண்ணணும். ஓகேவா? So whenever you get the chance, get the audience and present it. ஓகேவா? Few module 3 also we will expect the same kind of thing. If you people are willing, give your name in advance. Thereby we will allocate the title in advance. Thereby we will create the slides. Anything else you want to discuss? Sajid sir? Sajid sir?
Yes, sir. I think Yogesh வரையும் இமேஜ் தான் பேஸ் பண்ணி இருக்கிறது பிபிடில. அது கொஞ்சம் அவாய்ட் பண்ணே நல்லா இருக்கும். மீதி பிரசன்டேஷன்ல நல்லா தான் இருந்தது. ஈக்குவேஷன்ஸ் எல்லாம் பிபிடில எப்படி போடணும் தெரியலன்னா கேளுங்க, சொல்லிக்கலாம். புரியுதா? இமேஜஸ் போடுறது கம்மி பண்ணுவோம். அப்புறம் சென்டென்ஸ் ரொம்ப பெரிய சென்டென்ஸ் போடுறதுக்கு பதிலா பாயிண்ட்ஸ் மட்டும் போட்டுட்டு பாயிண்ட்ஸ் நீங்க எக்ஸ்பிளைன் பண்ணுங்க. அவ்வளவுதான். மற்றபடி மீதி எல்லாம் நல்லதா இருக்கு.
Okay, sir. Thank you, sir.
Okay, sir.
see next time onwards ஒரு ட்ரையல் பார்த்துக்கோங்க நீங்களே, சரியா? ப்ரெசென்ட் பண்ணி பார்த்துட்டு அப்புறம் கிளாஸ்க்கு வரணும். Any doubts from your side? Else we will conclude the class.
Sir, I'm sorry, sir. There's actually another biasing, sir.
அதுக்கெல்லாம்
class attend